In this video, we are going to be talking about Wolff Kishner reduction. We learned that in Clemenson's reduction, aldehydes or ketones, that is carbonyl compounds, are getting reduced in the presence of zinc amalgam and HCl to give us an alkane and water. Clemenson, that is Clemenson. This is Wolff Kishner. So the difference over here is going to be the reagents. But then the product is the same. The byproducts are obviously going to be different because the reagents are different. So in Clemenson, I'll just write it over here. In Clemenson, we used zinc amalgam and HCl. So this is the reagent for Clemenson. Both of them are giving us the same alkane as the main product, but the byproducts are going to be different, obviously. So in Wolff Kishner reduction, what is going to happen is we are taking a carbonyl compound again. So when a carbonyl compound is heated with a mixture of hydrazine and a strong base, and this is done to heat it up to 453 to 473 Kelvin in ethylene glycol, we will get an alkane. So a carbonyl compound first reacts with hydrazine. Hydrazine is NH2, NH2. Okay, when this happens, or one sec, let me just write it as hydrazine. One second. So it's reacting with hydrazine. It leads to the loss of water. Okay, and this leads to the formation of a compound called as a hydrazone. Okay, and this hydrazone is heated, is going to react with a strong base and is heated to 453 to 473 Kelvin to give us a hydrocarbon. So, in Clemenson, it was just one step, but in Wolff Kishner, it's a two-step process. So, when a carbonyl compound is reacting with hydrazine, there is a loss of water and leads to the formation of something called a hydrazone. And this is reacting with a strong base and heated to give us a hydrocarbon. So, obviously, the byproduct over here will be different. We'll have another byproduct over here, that's nitrogen. In case of Clemenson, it was just water. So let's take the general reaction. So we're taking a carbonyl compound. Like I told you, if both of these are R groups, it's a ketone. If one of them is R, the other is H, it's an aldehyde. So this is reacting with hydrazine. And this leads to the loss of water. And this forms the hydrazone, NH2. Okay, so here basically oxygen from this H2. So H2O gets removed. It's getting kicked out. So it leads to the formation of a bond between carbon and nitrogen. Okay, now this is going to undergo reaction in the presence of KOH, which is a strong base, or ethylene glycol, and is heated for us to get a hydrocarbon plus nitrogen gas. Okay, another example, let's take an example of an aldehyde. So CH3CO, ethanal, is reacting with hydrazine, and this leads to the formation of a hydrazone. So if you find it easy to just use this as the template and write the reactions, you can just replace this with CH3. Here you can write a H and write the reaction as it is. Okay, if it is easy for you. Whatever you do, make sure that you write the right reaction, and it's very easy. It's all very easy. An NH2 and a H. This is reacting with KOH and 453 to 473 Kelvin heated and glycol to give us ethane plus nitrogen gas. Now let's do one thing. Let's just replace the carbon, replace these gap with a CH3. We are going to take propanone. Think about it. The product over here is the same as what we found for Clemenson's as well. The only difference between these two is the fact that we are using a different reagent. So CH3, C, double bond, N, NH2, and you have another CH3 over here. Okay, and this undergoes the reaction with KOH, the same conditions. I'm just putting a ditto mark. Don't do that in your exam paper. So CH3, C, H2, CH3, that's propane plus nitrogen gas. Before I conclude this, the reason I keep saying that it's very similar to Clemenson, I am trying to see where the space is. Okay, fine, I'll write it here. So in Clemenson's, we had CO, ZnHg, HCl, CH2 plus H2O. This is the reaction for Clemenson's reduction. Okay, look at the reaction of Wolff Kishner. In the end, we are getting an alkane in a hydrocarbon in both these cases, right? But in case of Wolff Kishner, you're using hydrazine, we are getting a hydrazone, and that is undergoing reaction with a strong base, and on heating is giving us a hydrocarbon. This, on the other hand, is just a direct direct reduction reaction. Remember, don't learn these two reactions separately. If you do that, you are just wasting your time in terms of trying to memorize two different reactions. They're basically the same. The difference is the reagent, but the reactant and the end product that we're getting are the same. In case of Wolff Kishner, we have an extra step. So with that, we're done with Wolff Kishner. Carbonyl compound is undergoing reduction in the presence of a strong base. First of all, it's undergoing reaction with hydrazine to give us a compound called as a hydrazone, which on reaction with a strong base it's giving us a hydrocarbon. With that, we're done with Wolff Kishner reduction. In the next video, we will be talking about Felling's test and Tollens test.